It's been a while since we met each other, and this is the reason why I want to make a very personal confession. You need to know that I am obsessed with David Lynch, the American filmmaker, an absolute genius in my opinion, the one who wrote, produced and directed Twin Peaks, one of the first TV shows. In Italy, it was 1991 and I was only 19 years old, and I was totally impressed, hypnotized. In fact, I bought the box and I watched the show regularly. I think I watched it 7 times, and that's why I know everything, any single detail, believe me. I also remember, if I'm not wrong, that a couple of years ago, I wrapped myself in plastic, just like Laura Palmer, to test the feeling. Anyway, after this confession, I'm sure that you will keep this image, very professional by the way, in your heart. And speaking about heart, among the several masterpieces of our David Lynch, that by the way has my name, just to let you know, there is also Wild at Heart, that won in 1990 the Golden Palm for the best movie, and that of course I suggest you to watch. I don't want to deep the subject, but I just want to tell you that if in that movie the heart was wild, and now we come to the subject of today's episode, our heart today is black, very black. In fact, today we are going to talk about a phenomenon that is called black heart, or even better, black core. That is a defect that appears in the middle of the ceramic body and that deserves an entire episode of our podcast. I am Davide Trentini, and this is Apparently Invisible, Chemistry in Ceramics. Let's start with a definition. The black core is a localized area marked by a brown, black, or even white color, clearly visible in the thickness of the ceramic tile. Its presence is usually a sign of improper oxidation, and it is not to be considered as a defect that compromises the product functionality, unless the black core comes with a swelling. An important note to add, still remaining in the field of definition, is that oxidation is a reaction by which an element or compound loses electrons, giving them to another substance. More generally, we could say that we are talking about a combination reaction with oxygen. To put it shortly, or even better, to make it simple, do you know the cremino, the typical cube-shaped chocolate consisting of 3 layers? The black core is exactly that, a stripe of a different color, usually darker but sometimes lighter, clearly visible even after the firing process. That said, and going back to the definition, it's important to underline that the phenomena of swelling that sometimes arise in the thickness of the tile are now quite unusual. And that's because the inorganic raw materials currently used in ceramic production are, to a larger extent, with a low content of organic that are remain responsible for the problem. In other words, today the content of organic carbonaceous product is usually very little. But beside the organic compounds, we also have to consider the increasingly higher densities of ceramic mixtures. Why? Well, higher densities, of course, positively affect the industrial productivity, and this is the reason why they are strongly requested by producers. However, at the same time, they can be a problem for the proper expulsion, or we could say evaporation, of the organic material during the pre-firing phase. And the organic material, as you could imagine, since it remains within the ceramic body, has to be considered one of the main responsible for the problem. The black core, however, is not to be considered as a technical defect, but as an aesthetic defect. In fact, it has been proven that in many cases, its presence may even increase the mechanical resistance of the ceramic material. But the question arises, if it is not a technical defect, why do we consider it a problem? Let's try to give an answer. Even if the presence of black core does not affect the technical features of porcelain stoneware, it's now a very interesting topic due to the increasingly different intended use of ceramic material. What do I mean? I mean that today, ceramic tiles, especially big slabs, are not used only for coverings, wall and floor, but also for kitchen countertops, tables, and more generally for furnitures. Think about it. For this reason, the thickness of the material can be visible, and so it must not have any aesthetic defect. It might seem a trivial reason, but I assure you that it is not. But after this introduction, let's enter the heart of the matter, taking a step back to the origin of the problem. And of course, we do it with a chemical and physical approach. The roots of the problem are usually in some components, both organic and inorganic, that before the sintering process do not find inside the tile, and more specifically at the center of the thickness, the chemical physical conditions to uniformly react, such in the other part of the ceramic body. This different kind of reaction can keep or hold the organic material inside the tile even after the sintering process. That is the process that we could say, in very simple words, compact the solid particles of the raw materials in just one solid mass. And the lack of expulsion of the organic materials, and we have reached the point, is basically due to the very short firing times. I repeat it, very short or too short firing times. And so the question is, what can we do to let our organic components to leave the tile before the sintering process? Let's try to make a short list starting from those actions that can be taken even before using specific chemicals. Actions that are mostly about the setup of the production line. But before starting, I just want to underline that the following simple suggestions are only a short selection among the very long list of possible intervention. Suggestions that have to be tailor-made according to the conditions of each production line. So, first of all, we could slightly decrease the density of the raw tile by reducing, for example, the pressure on the support during the forming or pressing phase. This arrangement, and I'll tell you very simplistically, creates a wider net, we could say, that allows the organic component to leave more easily, we could say, the tile. A second option is the use along the glazing line of products that at low temperatures are not marked by a too low melting point. This means, in other words, to use products that do not merge before the organic components that are usually responsible and that can lead to the black core formation had the time to properly leave the ceramic body by evaporation before the sintering process. It's a matter of time. The third option is surely extreme and decisive, but surely a little bit unrealistic because it negatively affects the industrial productivity. What am I talking about? We could differently manage and so increase the times of the firing cycle. The reason is quite obvious, but at the same time, we also know that it's basically impossible. So let's go further by addressing a different kind of action that is not about the setup of the production line and of the application machines. What can we do on a chemical level? Well, the most effective action is the use of chemicals that can be added both at the grinding stage or inside the barbottina that bring into the ceramic body some kind of molecules able to provide with oxygen the organic substances and so to promote a better degazing process during the pre-firing phase. What do I mean? I mean that oxygen promotes the formation of organic molecules that at the temperatures of the pre-firing stage leave the tile in gas form in the proper times to avoid the problem. We could say more precisely that the use of these chemicals ensures that the oxygen turns some of the organic molecules of the ceramic mixture into more elementary forms until the formation, at the best, of carbon monoxide or oxide. There are gas able to leave the tile before sintering. We find a need to add that the black core, especially in the most colored mixtures, sometimes may come from pigments that are in an oxidative state different from what they should have to properly develop the requested color. What does that mean? Let's try to put it simple. We use the word oxidative, so I give you a very short definition of oxidative state. The oxidative state of an atom defines the numbers of electrons in the atom's outermost electronic band. And in case of oxygen deficiency, that in ceramics is synonym of reducing the atmosphere inside the kiln, the pigment can move from an oxidative form to a more reduced form of oxidation. That is a form in which the pigment could change its color. In other words, the atmosphere inside the kiln during the firing cycle, whose nature can be both oxidizing or reducing, is very important since it can affect the color of the ceramic mixture. This means that according to the condition inside the kiln, the pigment may unevenly change the color, sometimes leading to a black core. In fact, it's clear that the deeper parts of the tile, we could say the central part of the tile thickness, do not undergo to any oxide reduction process because it is less in contact with the atmosphere of the kiln. To better understand this last topic, that is the relation between the oxidative state and the change of color, and we are almost at the end of today's episode, I want to give you an example that has nothing to do with the ceramic production, but that can give you, I think, a clear idea. We now talk about blood. Yes, because even the blood, according to the oxidation level or oxidative states of the iron, can significantly change its color. The arterial blood, in fact, is rich in oxygen, and so the iron is marked by an oxidative state that makes the blood bright red. On the other side, the venous blood, poor in oxygen and marked by a different oxidative state of the iron, of course, is dark red and dull. So, now we also know the different colors of blood is due to a different oxidative state. Wonderful. But going back to ceramics, in all those cases, when the black core is due to a different state of oxidation of the pigment, it is possible to act with specific chemicals able to affect and change the oxidation state of the pigment by standardizing its tone to the rest of the mass of the tile. In other words, it is possible to act by developing real redox reactions. And with this bloody ending, that by the way is perfect for an episode that talks about heart or core in our case, we have come to an end. I remind you, as usual, that all episodes of the podcast are available not only on the main platforms such as Spotify, Apple or Google Podcasts, but also on our app that you can download for free on Apple Store or Google Play. You can find it by typing that and as Ceramco, Ceramco. I finally go back to my beloved David Lynch and to his ingenious madness, and still wrapped in Laura Palmer's plastic, I greet you. Just a final warning. Remember that owls are not what they seem. See you soon.